Why can't anything go faster than light? Simple question. You've heard the answer 1,000 times. Einstein said so. It's the cosmic speed limit. Nothing beats 299,792,458 meters per second. That belief is not a little wrong, fundamentally wrong. Light doesn't move fast. Read that again. Light doesn't move fast. Everything else moves slow. And the difference between those two statements, that's the difference between memorizing physics and actually understanding reality. Here's a fact that should stop you cold right now. A photon, a single particle of light, experiences no time, none. From the photon's perspective, it leaves a star and arrives at your eye in the same instant. A journey of 8 minutes from the sun, 0 seconds for the light itself, a voyage across the entire universe, still 0. That's not poetry, that's measurement. Richard Feynman, the Nobel Prize winner who played bongos, cracked safes, and rewrote quantum mechanics, discovered something about light that most physics teachers still don't explain properly. He found that light doesn't travel in a straight line. It takes every possible path simultaneously, every single one. And when you calculate what happens when all those paths combine, you get the speed limit, not as a rule, as an inevitability. The universe doesn't post a speed limit sign. It builds the limit into the fabric of space-time itself. The limit is the structure, and you, your body, your mass, your stubborn matter, you're the one being restricted. Light isn't obeying a law. Light is showing you what freedom looks like when you owe the universe nothing. This changes how you see time, space, yourself. Let me show you. Pick up your phone right now. Seriously, do it. Turn on the flashlight. Point it at the wall across the room. The light hits instantly. No delay. No travel time you can feel. Just there. Now here's the thing. That light traveled about 10 feet, maybe 15. In the time it took you to blink, light could have circled the entire Earth 7.5 times. Not exaggerating. That's the raw number. But you didn't see it travel. You can't. Your brain processes vision at maybe 60 frames per second on a good day. Light operates at 300 million meters per second. The mismatch isn't close. It's absurd. Comparing a snail to a jet doesn't capture it. You'd need to compare a frozen glacier to an explosion. So you've lived your whole life with an illusion. The illusion of instant. The illusion that light just appears. The illusion that speed at some level becomes meaningless. Wrong. Speed doesn't become meaningless at light speed. Speed becomes the only thing that matters, because at that speed something breaks, something fundamental. The rules you learned in school, distance equals speed times time, those rules start to betray you. People say light travels fast, but that's just a label. Labels hide the machinery. Here's the machinery. Your phone flashlight sends photons. Those photons leave at sea, not because they're trying to go fast, not because they have energy to burn. They leave at sea because they have no choice. They have no mass. And massless things, the universe doesn't charge them for motion. No tax, no friction, no resistance from space-time itself. You're different. You have mass, and mass pays a price for every inch of movement. Light doesn't pay. Light goes free. And that difference between what pays and what doesn't, that's where Feynman started pulling at the thread. Hold that thought. Here's the part nobody tells you. The speed of light isn't about light. Let that land. The speed of light, 299,792,458 meters per second, has nothing to do with light specifically. Light just happens to travel at that speed. But the speed itself, it's something deeper, something baked into the architecture of the universe. It's the speed of causation. Think about what that means. If you punch a wall, your fist affects the wall. Cause creates effect. But that effect can't ripple out infinitely fast. The universe has a maximum rate at which any cause can produce any effect, anywhere, ever. That rate is c. Light doesn't define the limit. Light reveals it. Like a car that perfectly maxes out the speedometer. The car didn't create the speedometer's maximum. It just reached it. Now here's where it gets even stranger. This limit isn't enforced by some cosmic police force. There's no barrier you slam into. No wall at the edge of 2999, 592, and 458. The enforcement is weirder. The enforcement is geometry. Space-time itself warps to protect the limit. Try to accelerate toward light speed, time slows down for you. Your length contracts. Your mass increases. The faster you push, the more the universe pushes back. Not with force, with mathematics, with structure, with the shape of reality folding around you like a trap. The universe keeps strict books on this. You cannot cheat. You cannot sneak past. You cannot accumulate enough energy to brute force through, because the energy required approaches infinity as you approach c, infinity. The universe prices you out. People say nothing can go faster than light, but that's just a label. The truth, nothing can go faster than causation, and causation moves at c. So why does light hit this limit exactly? Why not 90% of c? Why not half? Because photons are massless. Mass is debt. Mass is what you owe the universe for existing as a thing. Photons owe nothing. They carry no debt, so they travel at the maximum rate, the speed of pure causation, automatically. You've never seen your phone flashlight the same way. That little beam, it's not just bright, it's unburdened. It's what motion looks like when space-time charges you nothing. Exactly. This is where Feynman enters the story, and everything gets stranger. Princeton, 1942. A 24-year-old Richard Feynman sits in a seminar room, chain smoking, scribbling diagrams that make no sense to anyone else. He's supposed to be solving practical problems for the war effort. Instead, he's obsessing over something that's bothered him since childhood. How does light know where to go? Seriously, when light travels from point A to point B, it takes the shortest path, the fastest route, every time. But how? Light doesn't have eyes, it doesn't have a brain, it can't calculate distances before deciding which way to travel. Your physics teacher skipped this part. They told you light travels in straight lines. They showed you ray diagrams, neat arrows on paper, but nobody explained the why. Nobody touched the weirdness underneath. Feynman touched it, and what he found collapsed the entire picture. Light doesn't take one path. Light takes every path, simultaneously, every possible route from A to B, the straight line, the curved detour, the insane zigzag through the next galaxy and back, every single option, all at once. Wait, if light takes every path, why do we only see straight lines? Why doesn't your flashlight beam wobble in random directions? Here's the trick. Each path carries a phase. Think of it like a tiny spinning clock. When light arrives at point B via different paths, all those clocks arrive spinning at different angles. Most of them disagree. Most of them clash. They cancel each other out. Destructive interference. Gone. But one set of paths agrees. The paths close to the shortest route. They arrive with clocks nearly synchronized. They reinforce each other. Constructive interference. And that reinforcement, that's the beam you see. Feynman called this the path integral formulation. Brutal name, beautiful idea. Light doesn't choose the fastest path because it's smart. Light explores every option simultaneously, and the options that survive are the ones that agree. The speed limit emerges from this process, not as a rule imposed from outside, but as the only result that doesn't self-destruct. The universe doesn't post speed limit signs. The universe builds roads where only one speed survives. Feynman didn't just explain light, he revealed the accounting underneath reality. Every possible path gets calculated. Most get canceled. What remains? What you call physics. This isn't preference, it's bookkeeping. So far we've learned light isn't fast, it's unburdened. The speed limit isn't about light, it's about causation. And light finds its path by exploring all paths at once. Now let's prove it. Get on a train. Not a real train, a thought experiment train, Einstein's favorite tool, Feynman's too. You're standing in the middle of the carriage. The train moves at half the speed of light, ridiculous speed. Impossible for real trains. But stay with me. You hold a flashlight, you point it toward the front of the train, you click it on. Now here's the question. How fast does that light travel relative to someone standing on the platform outside? Your intuition screams the answer. The train moves at half light speed. The light moves at full light speed relative to you. So add them together. The outside observer should see light traveling at 1.5 times c, right? Wrong. The outside observer sees light traveling at exactly c, not faster, the same. This is where your intuition fails completely. You added velocities. The universe doesn't add velocities, not at these speeds. The math breaks. Addition betrays you. So what gives? Time itself adjusts. From the platform observer's perspective, your clock on the train runs slower. Your ruler is shorter. The measurements you make inside the train don't match the measurements made outside. Reality itself shifts to protect the constant. Light doesn't negotiate. You thought you'd catch light by moving toward it? Time dilates. You thought you'd make light faster by throwing it forward. Length contracts. Every trick you attempt, space-time counters. The speed limit isn't enforced by blocking you. It's enforced by bending reality around you. Think about what just happened. You tried to break C with simple addition. The universe answered by rewriting time, by rewriting space. That's not a law. That's architecture. Pull out your phone again. Open maps. Watch that little blue dot find you. Within 10 feet, maybe 5. Pinpoint precision. You use this daily, casually, without thinking. Here's what's actually happening. 20,000 kilometers above your head, satellites carry atomic clocks. Those clocks send signals down. Your phone receives signals from 4 satellites minimum. It compares the tiny time differences, triangulates your position. Simple enough. Except, those satellites move at 14,000 kilometers per hour, fast, and they orbit far from Earth's gravity well, high up. Both of these things matter because velocity affects time and gravity affects time. Einstein's relativity, both flavors operating simultaneously on the same clocks. The satellite speed makes their clocks tick slower relative to you, about 7 microseconds per day slower. Special relativity. But their altitude farther from Earth's gravitational pull makes their clocks tick faster, about 45 microseconds per day faster. General relativity. Net result, satellite clocks gain roughly 38 microseconds daily compared to ground clocks. Sounds tiny. It's not. Light travels 300 meters in 1 microsecond. 38 microseconds of error, 11 kilometers of drift per day. Your GPS would be useless by lunchtime, so engineers pre-adjust the satellite clocks. They deliberately set them to tick at the wrong rate before launch, so that once in orbit, velocity and gravity warp time, and the clocks end up synchronized with Earth. Let me say that again slower. We build clocks designed to be wrong on Earth, so relativity makes them right in space. This isn't theory. This is your phone working right now, because the speed of light is absolute and time is negotiable. Reality doesn't issue refunds. Engineers just learned the accounting. 15 kilometers above your head, right now, cosmic rays slam into the atmosphere. High energy collisions, violent impacts. And from that violence, particles are born. Muons, tiny, unstable, doomed. A muon's lifespan, 2.2 microseconds. That's it. Blink and it's gone, decayed into something else. Now do the math. Even traveling at 99% of light speed, a muon should only cover about 660 meters before dying. Not even a kilometer. Nowhere close to Earth's surface. But here's the thing. We detect muons at ground level constantly, millions of them, hitting the surface, hitting you. Impossible, unless time itself stretches for the muon. At 99% of C, time dilation kicks in hard. From the muon's perspective, the journey takes 2 microseconds. It lives its full tiny life. But from our perspective, the muon's clock runs slow, dramatically slow. Its 2 microseconds stretch into nearly 30 microseconds of our time. That's enough. That's enough to cross the atmosphere, to reach the ground, to reach detectors, to reach your skin. Wild. The muon doesn't cheat death. Time cheats for it. And here's the flip side, equally strange. From the muon's perspective, it lives only 2 microseconds, but the distance it needs to travel, that contracts. The atmosphere literally shortens in the muon's frame of reference. Both perspectives agree on the outcome. Both perspectives use different measurements. The universe keeps strict books on this. Same result, different accounting. Moons prove that time dilation isn't abstract mathematics. It's measurable. It's happening right now. Particles are reaching your body because space-time bends to protect C. The constant is enforced, always. Stop. Everything you've heard about light speed is backwards. People say light is fast, but that's just a label. Here's the reframe that changes everything. Light isn't fast. Light is free. You aren't slow. You're taxed. Mass is the tax. Every particle with mass carries debt. The Higgs field, that invisible molasses filling all of space, grabs onto massive particles, slows them, drags on them, charges them for every movement. Photons, massless. The Higgs field can't grip them. They slip through. No friction, no resistance, no tax. So photons automatically travel at the maximum speed, the speed of causation. They can't go slower. They have no choice. Freedom isn't an option for light. It's a requirement. Now flip the lens. Look at yourself. You have mass, lots of it. Every atom in your body interacts with the Higgs field. Every step you take, every movement you make, taxed heavily. You're wading through invisible resistance every moment of existence. This isn't metaphor. This is structure. The universe builds 2 classes of existence, massless things, photons, gluons. They travel at C automatically. They experience no time, no distance. Everything is instant from their perspective. Massive things, you, me, planets, stars, we're stuck below C permanently. We experience time. We crawl through space. We pay the tax. Here's the part that should haunt you. From a photon's perspective, you don't exist across time. You're a frozen statue, a snapshot. The photon sees your entire life, birth to death, as a single still frame. You experience decades. The photon experiences nothing. Same universe, different accounting. Light doesn't care about your journey. Light is the journey. Instantaneous, complete, unburdened. You think you understand speed. You don't. Speed is just how much the universe charges you for motion. Light pays nothing. You pay everything. So what did Feynman actually uncover? Not just a calculation trick. Not just path integrals. Something deeper. Something that should collapse how you see reality. The speed of light isn't a feature of light. It's a feature of information. Nothing, no signal, no particle, no influence can transfer information faster than C. Not because of some cosmic rule book, because causation itself has a speed limit, because the universe processes reality at a maximum rate. Quiet. Think about what that means. The universe is computing constantly. Every interaction, every event, every cause producing every effect. And that computation has a maximum clock speed. See, light doesn't move fast. Light moves at the speed the universe thinks. Feynman saw this in his path integrals, in his sum over histories. Every possible path calculated, every option explored, the universe running every scenario simultaneously, and only allowing results that don't contradict themselves. Reality isn't what moves. Reality is what's allowed. The speed limit isn't a restriction. It's the processing speed of existence itself. And here's where it gets even stranger. You're not watching the universe from outside. You're inside the computation, made of it, bound by it, running at its clock speed. Beautiful. So here's where we land. Light speed isn't about light. It's about the architecture of reality. The maximum rate anything can influence anything else. The universe's processing limit, the clock speed of existence. Feynman didn't just do math. He pulled back the curtain, showed us the machinery, the bookkeeping underneath every photon, every interaction, every moment. So far we've learned light isn't fast, it's untaxed. The speed limit isn't enforced, it's built. And reality isn't what happens, it's what survives the accounting. Do this tonight. Turn off the lights. Take your phone flashlight. Shine it across the room. Watch that beam hit the wall instantly. And remember, that light isn't moving fast. That light is showing you what freedom looks like. You're the one paying the tax. Now, what else have you been seeing wrong your whole life?